I have a difficult decision this morning. I was trying to see what I should wear for this special occasion because am I a tech geek or am I a business person? So this is my result. It's a t-shirt with a suit, right? So this is how I started my days at Phison US. I'm the president of Phison US. This is how I started with the Phison journey in the US. I started as a FAE. I go into the lab. Yes, I solder stuff, making sure it works, run the performance, give it to the customer. And then while I'm waiting for the product to run, I went over to the other room and present my roadmaps, right? So this is a Phison style. We are an engineering company, but everyone is passionate about business. Everyone is passionate about the things that they design, right? So I'm gonna tell you a little bit about Phison story. So like the introduction says, Phison is everywhere. Actually, every 1 out of 5, any NAND flash storage device have some kind of a Phison technology in it, but we always have been under other people's brand, right? If you look at our revenue, $2 billion company, we are publicly listed in Taiwan. I asked you who knows Phison 5 years ago. Nobody knows, okay? But we actually started 25 years ago. This is our 25th anniversary. And we started creating the first single chip USB. We pioneered this technology. And fast forward, today we're going to talk about from a 16 megabyte USB drive. Who remember that? All the way to 122 terabytes of data storage today. That's how crazy it is. Look at the head counts. 4,500 head counts in the whole corporation, but 75% focus on R&D. So we use our partners to do marketing, to go to market for the storage side for the past 24 years. And we are just an engineering arm behind them. My lab is their lab. They don't need to have an SSD team. They use us as their SSD team. What our business focus is, this morning you hear about adaptive AI, a very creative way to use a NAND storage to solve an solvable problem of model scaling, right? So nobody, I think there was one question about, hey, how big is the market? And guess what? We go to every customer, they ask the same question, right? But nobody is really looking at this as a problem because they can't afford it. They're not trying to, they take what they have on the public model, right? And they make the best use of it, right? But we're saying that, hey, now you have another way to actually make your model better. And if you hear the chief NVIDIA CEO says, own your own AI. But how do you own your own AI without your own data or model, right? How do you keep it on-prem, right? So enterprise AI is a big focus now, but our bread and butter is still storage. That's what's our paycheck today, right? And enterprise is our highest priority right now because that's the biggest data growth today. Is smartphone scaling big now? Is laptop scaling big now? No, right? How many USB drive do you need? When's the last time you used a USB drive SD? No, right? It's in the data center, right? It's the data, AI at the cloud, and AI at the edge.
So what's the percentage between consumer and enterprise right now?
So 3 years ago, it's 5% out of the 2 billion.
Oh, wow.
Okay? 2024, last year, is grow to about 12 to 13%. So it is going to take over our company's revenue very quick. Or I should say that if it's not 30, 40% of our revenue, that means we're not catching up with the growth, right? So we are very much, that's why we have a local enterprise lab sitting in Colorado. They have hundreds of years of experience combined, all the people that used to do actually hard drive in the validation for, it's a partnership with the Seagate, right? Mm-hmm. So they have a lot of experience. for making sure that we capture this market well.
I got to believe the margins are much better as you go into enterprise as well. Consumer tends to be very narrow.
Well,
margin.
it depends. If you only create a cookie cutter product that everybody has, yes. How much? 3 cents, 4 cents per gig, 5 cents a gig, right? But we're doing different today, and that's what we're going to share with you. We are global. We are global. So 4,500 headcount total. We have our heart of the R&D, and you're going to see that, engineering, you could see storage, right? It's a controller, it's a NAND, how hard it is. Actually, the magic is in the firmware. It's very difficult. So one thing that we do very well is we have our core engineering in headquarters, while we have regional office in the US, in Malaysia, in China, in Japan, and in India. So one of the things that we have observed is that be able to be good at selling your storage on every regional, it's not just plainly created a lot of regional office, right? It's about how do we work with the local partner and create like a JV. So we did that with India. We announced it earlier this year. We create Malaysia office that's going to launch next month, right? My storage is focusing on design in Malaysia, manufacturing in Malaysia, for the AI infrastructure in Malaysia. So Phison go to market on regional. You will see Malaysia, India, China. How do we work with the local partner, either in the form of JV or other kind of arrangement, and create a local king that has local personality, local channel, local network, right? And then in the US, we position as a technology kind of pioneer for the company. We talk with what are the biggest tech company in the world today? It's all here. Who get the fastest requirement? It's all here, right? Our CTO office is here. So that's what we want to be. We want to be the pioneer, drive the direction of the company, and also have a local enterprise lab to serve the local customer.
What about in Japan? Is that R&D or is that just local sales office?
It's a FAE office and then business.
Okay.
Over there, right? Okay, let's take a little roadmap here. It's very busy. I'm just gonna pick out a few ones. So 2000, we started with a USB. Actually, I have a encounter with ex-Intel CEO Pat Gelsinger, and he said that he's the one that actually revived a USB interface from Apple tried to do the proprietary, and he saved. And I walk up to him and I say, "Hey, thank you. Without you, USB, we won't be here," right? So that's how we started. And then quickly, if you in the 4 years, we became the fastest company that went to IPO in Taiwan. 4 years, and we are making money.
Nice.
Okay, and then 2008, 2004, same year, the whole world moved to the digital card. If you remember those days, and in 2008, we went into industrial solutions. Nobody liked to do industrial solution. It's so much customization. It's high customization and high mix, right? We do it. We do it behind our partner. And then the world go into the Ultrabook in 2010, right? And then all along, we have, and then eventually it went to the regular notebook, and then eventually it took over the entire notebook, and then the enterprise. So every single part of the journey of every product segment, because of our dedicated engineering, we always shoot for the best, fastest to market. We always have been the leader of every single segment as we move on, right? And one thing that I'll share on the next slide is you're going to hear these two words a lot today, world's first. Before 2018, the world's first belonged to a Korean NAND manufacturer. Oh, what's the latest Gen 3? Yeah, Samsung. When is the first whatever? It's all NAND makers, right? That all changed in 2019. Who is the first SSD client? Phison. Who is the first Gen 5 SSD? Is Phison. That all changed. Want to highlight a few awards. So we are in space. So because space has such a big demand in storage. No, come on, no.
A lot of data.
No, not
Infinite
yet.
market.
Not
Infinite
yet.
market out
But if Elon Musk want to go to Mars, data needs to store somewhere, right? So when we took on this, we said,
Digital version.
engineering say, KS, our CEO, why do we want to do this? Hey, this is a representation of our commitment on, we keep saying we could customize and we say no to space. Come on, who can say no for people who really want to go to space, right? So we did it, right? 2000, we went to 2001, 2010, we went to Mars, so our Perseverance. Last year, we have a couple devices on ISS, and this year, our SSD is in a lunar mission to the moon. That happened 2 months ago, right? This is the very first data center that was hardware architecture on the moon, right? And then you hear about a lot of adaptive. That's something new. We also are being recognized a lot in the SSD. Obviously, you hear more about us in the client, but actually just yesterday, and you're gonna see a lot of review coming out of our Pascari X200 SSD. There's gonna be more review coming out. We're making some noise now, okay? Also, you see on the left-hand picture, there's a little, the mountain, the world's strongest man. That was last year, supercompute. Actually, we broke the record in a good way and a bad way. What in a bad way? It's the first time they had to have officials come in and said, hey, you guys are drawing too much cloud. This is calling a fire hazard. So we had him lifted thousands of SSD, 122 terabyte in one lift and broke the highest density that ever lifted by a human being, right? So thanks to my marketing team, that was a very creative idea, okay? On the right-hand side, very small, I'll help you read it, automotive. So have you guys heard about dual port drive? Dual port, enterprise, okay. So let me tell you, all the drive usually today, a lot of it is single port. Right. But dual port drive was used more, but it's still here on the OEM side, right? Dual port, right? Because it's for data protection, right? Automotive, how many ports do you think we need? Automotive. It's just a car. It's not like data center. It doesn't run NVIDIA's super power GPU or whatever, right? Well, they also have a product, but they don't use that crazy product over here. You're looking at a quad port, SSD for the first time. We work with a partner, right, to release it to the market. So you're looking at a data center on wheel. And what they're doing is combining all the elements in the car. You have one for ADAS, the dashboard, every single part coming in here and managed by a single storage that they can orchestrate. Right now, there are a lot of AI applied to a car, automotive car. So, you know, by combining all the storage, right, you could do a better orchestration. And we're the first one that makes a quad port SSD controller, and we didn't make it for data center. We actually did it for the car. So you're gonna see more and more of these coming out. It's called centralized architecture for automotive. We've been growing very healthily. You look at this, it's a good growth. But one thing that is behind the scene, every year, NAND price erosion is about 40%. So think of how much we have to ship every single year to keep the growth. It's crazy. It's crazy. And why we are in the enterprise? Because even if the units are not growing, the capacity is growing like crazy, right? So we're able to hit the 1 billion in the first 10 years. We hit another billion, 2 billion in 2020. And from 2021 to 2024, there's a big, price market dynamic, but we're still able to keep around 2 billion. And we believe that going forward, the future is really bright. And the reason why is, unless you are the world's first and you don't make the NAND flash, who cares about you? So this is always in our DNA. Not only we're going to keep selling more product, but we are going to be the world's first. And you see Gen 4 SSD first, Gen 4 QLC SSD, highest density 2.5 in enterprise. So we started enterprise actually 5 years ago. But we only branded our product last year under Pascari, what you see here, right? But we created right now the highest density SATA drive, Phison. And then the Gen 5 SSD, also Phison. We're the world's first.
Is there something like a corollary to Moore's law, like you have with CPUs, as far as in storage, the amount of storage increases every year and how much the price goes down, or a rule of thumb?
Yeah, so for storage side, right, it used to be most companies are trying to get to the next process node every 18 months, right? And by going to the next node, I would say that not every single transition, but every 2 transition, you usually would double the density. So meaning
months.
that it's like a tick-tock, right? You have one generation, you shrink the die. And then another one, you shrink the die further, and then you double the density. So right now, a single die density now is 2 terabits. So a little chip, a single, you see the SSD, there's a lot of chip, but every chip actually is stacked with a different die. And each die, even one die, is 256 gigabyte, one die, right? So this is why even cell phone you're seeing that 512, 1 terabyte, right? So there is a 18-month, but I think that if you see the market dynamic right now, because NAND flash, there's many players, there's many up and down. So people are trying to kind of slow down the pace so that there's no like oversupply situation, right? Yeah.
And then the price with that, is it going down for as?
Yeah. So typically, my rule of thumb is that in terms of the pricing go down is that usually I would say every 3 years, maybe it will cut the cost by half. Yeah.
So follow on to that question is, do you have any progression of what the density per watt is?
Density per watt?
Yes.
Yeah, I don't have that detailed information, but in terms of the density right now, because of the single die, the 2 terabit NAND, right, each one. So you could actually, today we're looking at 122, right? Next year you're gonna see like 256, and all these devices had to be buy into a form factor that has a max limit wattage, right? So for the U.2, 25 watts, you have to crank 122 today. 256, you still have to be low at the 25 watts. That's why there's a new factor that E3.S that you will see today that is 35 watts, right? So in that example, you double the density, same wattage.
Yeah, but I mean, even when you get to the 122 gigabyte, you need to do power shaping inside the device to be able to manage it. So I was just wondering at the chip level, if you had plotted anything like this on what the density per watt is, because I'm guessing that also goes up as well.
Yeah, if you're talking about the density per watt, I think that it will go along the density scaling a lot, because every single generation, nobody can actually accept that you have higher power. But the performance, it doesn't like double every time, right? But it was, for example, when we started the first Gen 4, the performance at that time, the interspace speed, I think it was like a 1200. And then by the time we go to Gen 5, it's 3600, right? So that's 4 years. But wattage for die to die from when it's a 64 gigabyte per die to 128 to 256, the wattage, you cannot increase too much.
Okay.
Yeah. Patent is to protect our intellectual property, and you will see that majority of patent is behind the NAND, right? NAND applications, how we handle the NAND handling fee, and on the security side, we have majority of the important region covered. Okay, so what is different about Phison? And then that will fit into our Pascari story. So if there's one word that you remember today, is customization. And this is something that we do this a lot because we are behind the brand. So it's the DNA that we think that it is something that the enterprise market is missing today, okay? So we are customized ready. We have all the right ingredient in the technology stack because we are vertical integrated. So to make a NAND device, you have a controller, hardware, and then the IP inside the controller. And even the NAND maker, they actually don't design the IP within the controller. They outsource to different companies. We did not, because to get to the time to market, you actually have to own all the technologies so that everything works, perfectly, orchestra, perfectly. So we make from controller, firmware, hardware. We do the PCB board design. We make the entire device. We even design the housing for our customer, the custom heatsink for the customer, all the way to labels, shipping logistics. So we are, who makes the burger today? Is it McDonald's? No, right? But who is the most successful company today making burgers, right? So it's the business model. It's your mom's burger. Yeah. This is what's really ingrained in Phison is that we are vertical integrated, and then we have a lot of trusted partners that have been with us for a long time because what they get from us is not a product; it's a partnership. Let's talk about Pascari. So, why does the world need another enterprise SSD?
Oh, that's why it is Pascari. Okay, artificial intelligence security.
So Pascari come from, we are performance, we are artificial intelligence,
I like that.
we are security, capacity, we have the highest density today, acceleration, reliability, and innovation. That is Pascari. And our tagline is engineering, imagination together. So now, when we try to think what defines our personality, is engineering is actually what makes the product work, right? But our customers' requirement, do we want to always tie to what we offer as a standard product? No. What our brand's core value is that we want to blend our engineering and your imagination and working together. So do not tell us, hey, what standard product you have. Tell us what you need first. And we will see what product we have for you. This works, this works, this works. And if none of them work, you need a little tuning on the power. You need to have a special command because you are going to the moon, like special data login. Oh, sure, we'll do it. Well, the other company may do it if you cite them a big paycheck, or maybe you are the top 5 company, a large customer in the world. But small companies or special mission company to the moon, they don't have choice. They are settled with what you give to them. So we want to have engineering and your imagination working together. And like I said, it's a product. It's not just a product, it's a partnership. And that's what it takes to win for us. I mentioned about the enterprise growth. We'll add it to that on the next slide. And one thing that is special about us, everything that you see our enterprise drive, our high performance portfolio, is all dual port. And this is something unique. We have our Imagine Plus. We branded our customization service under Imagine Plus design service, from firmware to hardware flexibility. And we are not just customizing products. We're customizing business model. So let me ask a question. So with all the company that is trying to make an AI system, why did everyone try to design their own chip? I'm sorry, I'm supposed to get a question from you, but I would like to discuss why did they all have their own ASIC? They want something different for the AI. They want to save costs, or there's different reasons, right? And you have seen different ways to make the hardware, the form factor, everything. But who is providing that flexibility on the storage side? No one. So what does when the box company want to do something different, what do? So they actually try to make a SSD team. They try to build SSD team, right? Many companies have done that, and almost everyone failed to do that. You know why? Because when they really need to have their own SSD because of flash shortage and all that, it makes sense to build it yourself. They start building, and then it takes 3-4 years to finish. And then by the time they finish, it's cheaper to buy it off the shelf, right? So it's this cycle, and the largest company, I'll probably name a few after our session, it all fell, right? But when I say customization business model is, hey, you know what? You like our technology, and you have a good supply chain on the NAND. Hey, let's take your strength. Consign to me. I'll build it for you, right? So I think something that you see what we do differently is, yes, we have a standard product that everyone has, but we also have a capability to customize product and business model. And our fourth section is this. You will see a lot of big brand products out there today. They are focused on the mainstream, and they focus on the high end. The standard product, you will see some 1.S for a lot of GPU servers. You see M.2 for the mainstream for the boot drive. You also see the QLC drive as also what we consider mainstream because it's the value, the price per gig. And then you see the high end, which is, hey, give me the fastest drive, right? What we bring to the market today is 2 additional. We supply the legacy. We will continue to ship SATA drive. Yes, I know, it's old, but we'll continue to ship that. We are going to be the last vendor that's going to ship a SATA drive.
So, Michael.
You're welcome. Yes.
Hi, Kimberly Bates. And if I'm taking you down a path that you want to go down, that's fine. A kind of question that goes beyond all this. You guys are the big manufacturers. You supply so much.
Yes.
What is the plan currently in terms of the tariff issue?
Great question. Great question. Okay. This actually, yes, everybody is having their phone next to their ear for the last 2 weeks, right? Everybody knows the rule, right? Manufacture in US or manufacture in somewhere else to come in, right? There's a big movement, right? But who can actually make that change quickly? Right?
That's the big question.
So, yes, yeah. So I think that the core of the technology, the firmware and all that, the intellectual IP design in the region. But in terms of how to ship to different region, in this case, you mentioned about US, right? We have to be smart. We have to agile. We have to talk to manufacturer to actually manufacture the PCB board locally, right? Or in regions that has certain treaty to the US. And also, in the interim, hey, can we move the entire testing and everything like tomorrow? It's not easy, right? So, but we have very internal experts think of different logistic way and try to make it work, right? So it is a problem that every NAND vendor and actually, there are letters issues that most of people are going to pass the tariff to their customer, right? But that would actually slow down the event a lot. and that's a problem, right? So we need to provide a customer with the option that where they can, minimize the tariff. Yeah. Did I answer your question? I cannot say too much.
I don't think anybody
detail.
can answer
I cannot
any of
say
those
too much
questions.
detail. I will get in trouble. We are in the so-called process of moving the manufacturing over here. It's in process, and we are committed to our customer that we will help you with this.
And down that line, again, if I'm taking us down a line we shouldn't be going, I know it takes about 3 to 5 years to bring a fab on, or fabrication and that kind of stuff on.
May I interrupt?
Sure, please.
How about 3 months?
Okay, well, that's a different game.
Yes.
Very different game.
Yes, we cannot wait 3 months, because by the 3 months, my enterprise revenue cannot hit the 30% of our revenue,
so
right?
This is
we have to act
fast.
quick. We have to act quick.
Interesting. Okay.
Right. And then I mentioned on the top of the pyramid, custom design. So think of Phison as we have standard form factor, and we're going to strive to lead the technology. We announced a brand last year, and this very quickly, within a year, we announced the largest enterprise drive, right, ahead of many players right now. So we're going to have the best looking forward product, and on top of that, we are providing the customization. Due to the time limit, I'm going to skip ahead. In terms of form factor, I mentioned about so everything we have, right? Any single form factor that we have from legacy. So the trend that you are seeing is there's a lot of U.2. That's like a same pizza box at the. This is M.2, right? It's a 2.5 inch. It's trying to be the shape of the hard drive. And there are recent movement to move to the, where is it? Where is it, what I'm looking for? The 3.S form factor, you see E3. It's a thinner profile, right? And it has a short version and long version. And there's a lot of moved to E3 because you could actually fit more drive into a 2U form factor, right? And right now, we are also embarking a project, right, which actually take advantage of our capability. How do we replace a hard drive? How do we replace a hard drive? There's so many out there, right? Can we do a drop-in replacement? Can we have the thing is, every generation of NAND, people are trying to go the faster, right? But a lot of these AI data center, what they need is the capacity. And the cold storage, they care about the capacity. They don't care about the performance. So how do we design something that will hit that capacity point, super low power, so that we replace the hard drive, right? So we are under a lot of, this is our Imagine Plus is how do we design something that we can replace that?
Are form factors proliferating, or is there, because it seems tough to have all these different form factors and where they would have to go into.
Right.
Are a lot of them being retired and new ones coming up?
Yeah. Yes, like I said. So SATA, you see a lot of SATA in the more legacy platform. People, IT department, if they need to replace their drive, they still need a place to buy. U.2 is the most common today for the server data center. This is the U.2.
Okay.
Right? But then there's certain hyperscalers, they have used some unique one because they are self-consumption, right? They can actually have a very unique form factor because even though they are the only customer that buy it. So this is very popular, and then this is getting into the E3, which is over there on the very right side. The E3 form factor is thinner, right? It has two profile. Actually, the one the thinner profile and the larger profile. So these are the main ones. You're looking at this and the E3, and then you're gonna see the GPU server. They have a tiny little slots in the front. That's the E1.S. E1.S. There's a shorter, and it's getting more, pretty popular these days, right? So if you think of a GPU server that is running the actual GPU in the same server, you see a lot of 1.S. But if you're talking about the storage server only, you see a lot of the U.2 and then the E3 today.
So the
So it's kind of
D100
stabilized. Yeah.
the D100P, what are those for?
Oh, this is, you mean,
The real super thin and little ones.
oh, this one? Boot drive. Boot drive. So some servers, you need a boot drive.
Okay.
So it doesn't need a high capacity. It just need to have the power fail, power protection, and you know,
Okay.
to run the server. And you have a question?
Oh, I think one thing, kind of a corollary to what you were asking is, okay, so you've got all these different sizes of drives. Are you creating the different sizes of drives because the hardware is changing? Or do you have to, like, all the hardware manufacturers now need to be changing, you know, their drive?
Who
Oh.
sets the
Trace.
standards?
Oh,
Yeah.
yes.
It doesn't look like there are standards, really.
Yeah.
I guess,
Well, actually, there are standards
Yeah, I guess.
that define this. Every single one is a standard. Even if they don't start as a standard, they become a standard because one of the biggest thing about a storage, a server vendor is not having a healthy supply chain. They need to have different sources of NAND. So all these are the standards, and we have to have every kind of form factor covered. But something that I just mentioned about hard drive replacement and all that, right?
Yeah.
We are at the point of, you know, the reason why is this shape, and you're starting to see this kind of shape, because when we design SSD, everyone is like, okay, I need the shape of a hard drive. So everyone look like this. Okay? And then people say, hey, why do I need to live in this? Eventually, it's all going to this box. Why can't I design a triangle one or a round one or whatever? Of course, you're not going to do that. But why can't I design something more fittable to this? So you're starting to see this.
That's kind of floppy disks. The thicker one is like a floppy disk form factor.
Yeah,
Remember
exactly.
the old Z drives or what?
Which is that sort of square thing, yeah.
Right, like a lot of today, like a SAS drive, it's still there. It's still good for, they call it a nearline hard drive. It's a faster one, and also you have the cold storage one, which is, you know, and you know, if you look at the hard drive company, they're laughing. They're still laughing. There's still a lot of hard drive, right? But then over time, right, as an SSD vendor, we have to think of a way to how to get into that, and there is a way. So there are another form factor called E2 that's under evolving. It's a new form factor that's coming. So usually the typical cycle is the industry recognizes there's a need, and then people from vendor, the device, they will get together, and then they will think of a form factor, and then it takes about 3-4 years for it to be. Yeah, takes time. Getting. Oh. Okay. So one thing that you'll see differently is now, not only you see all this product on the OEM product, but you could actually get our product in the channel now. So we are in MATLAB, we're in Newegg, we're in ASI. We want to be available to the public. A very quick rundown. Chris will give a much detail. We have the high performance X series. We have the data center. That's the QOC drive. So every time you think of a large density, I don't know if you're familiar with the QOC. Is the most value NAND technology now. It has the largest density per wafer. So you have this let's belong to our data center series, and then you have the SATA legacy. You have the boot drive, and then this morning we talk about the 100 dry write per day for AI edge applications. Okay, I mentioned before, what do we do in the Imagine Plus custom SSD design? You know, we take actually NAND from everyone, faster to market, and we want to you know, build the next, you know, imagination, right, for you, AI and enterprise. Okay. We follow all the industry best practices, a lot of testing going on, and to meet all the demanding needs of the enterprise. So 6,000 testing hours. So every drive has to go through this called RDTs, right? And it's a very big investment. a lot of customers, they see this presentation I have in front of you. They was like, oh, great, oh, great. And then I said, can I take you to our validation lab? They see the lab and how much we invest. And they were shocked, right? There are a lot of investment behind all this, in the making of these drives.
So if it stops operating at 40,000 feet, how do you put it in space?
Yes. This is my last slide. It's because I'm a tech geek, so I need to speak some technical, stuff.
Thank you.
Of course. So I'm gonna tell you some magic
That's why
behind the curtain.
3 months.
So why are we able to be the time to market? Why? Oftentimes in the development of a product, you get the NAND, the chip, you get it in-house, and then you take about 3 quarters to make the firmware, test the firmware, perfect the firmware, make sure it works, about 3 quarters. So by the time the NAND is ready to your product ready, sometimes 3 quarters. But actually, if you're a NAND business, it's like a sashimi. The minute it's ready, you want to serve it. You don't want to wait because your job is to sell the NAND, right? How do we conquer this problem? Whenever you have a NAND, you take a 3 quarters to have the product. This is the reason. NAND emulator system. This is our secret ingredient. What that does is, before we get the sashimi, before we get the NAND, we actually have a system, it's a computer system that emulates itself as a NAND. And the benefit of that is, when my controller is in development, my firmware is in development, I already have NAND that I can play with, even before the NAND arrives in my house, right? And also another benefit is, usually when you have all this failure mode with the NAND, right? To make a SSD work, actually it's not that hard, but to make it run well and have all the checkbox click is difficult. So usually in the past, I would say, hey, can you give me a NAND? I want to see that retry issue. I want to get this issue that only happened in the high temp. I'll just keep getting all the NAND from the NAND vendors. But then it takes a long time to get that one golden sample that fell in that condition. Guess what? Why don't we create the failure with our NAND system? We create so this NAND emulator is like a computer system where it is a NAND, and it has all the failure system built into the library. And by the way, we are the only vendor that actually we can build product with the different vendors' NAND. So we have all the knowledge, right? So that's something that is really valuable to us to get to the market. That's why something I didn't mention is when we had our first Gen 4 SSD to the market, you know what? From the moment that we get a presentation like this, customers say, I want a Gen 4. Fast forward 9 months, only take 9 months, right? We got a product on the shelf. From an ASIC, not created, it's only on a concept. We build the ASIC, we build the firmware system, put it together on the shelf to align with the AMD's Gen 4 launch in 2019. Typical cycle for this is 2 to 3 years. We shrink it to 9 months. So that's something that I want to share with you.
So quick question. You talk about this SSD design validation.
Yeah.
And in the first slide that you use your SSD for missions in the space. Are you following the same design process validation, or is something?
Yeah, on the space, it's completely new.
It's completely
new. Yeah.
Yeah.
We had to actually ship to different special slice lab. The customer had to put some special shielding, radiation, vibration.
Yeah, because the radiation causes radiation there.
So so we don't expect you yet, right, to bring this standard product to the moon, but any special design. And the other reason that we do is actually a lot of technology can average onto our standard product, right?
Yeah.
That's why we did it. So you could see, like, from the experience or like how robust our PCB design. We use the industrial grade, all that. It could be actually baked into a standard product. But yeah, all the special kind of, whether it's going up to the sky or a few thousand feet below, everything has to be kind of special validated on the customer side.
Yeah. And it is so my curiosity. Is there a public paper talking about this validation, or are you solved or try to
Yeah,
solve?
we have a Phison blog.
Yeah.
We are actually starting to put a lot of the general Flash 101 validation, industry standard practice. It's been around for like 2 years. There's a lot of material. I'll share some information with you.